Hello, this is Sarah Bateman, and I'm introducing my group's topic on fluoride detection. So, our article was titled Rapid Detection of Fluoride in Potable Water Using a Novel Fluorogenic Compound 7-O-tert butyldiphenosyl 4-methylcoumarin. So, there are a few benefits associated with fluoride's presence in water. So, it is used for the growth and maintenance of teeth and bones. And when it was discovered that people who drank from water sources with naturally occurring fluoride had fewer cavities, fluoride began being introduced into drinking water. So these benefits also inspired toothpaste and other teeth treatment products. Fluoride isn't only associated with benefits. The article also mentions some harmful effects of fluoride. Higher levels of fluoride have led to decreased thyroid function, type 2 diabetes, attention deficit hyperactivity disorder, and neurotoxicity. These harmful effects make it necessary to monitor the levels of fluoride. Eventually, the United States Environmental Protection Agency recommended to lower the mandated fluoride levels that are added into drinking water. So it's now recommended that fluoride levels don't exceed 2 milligrams per liter. Fluoride's a naturally occurring mineral. It can become present in groundwater through the dissolution of rocks such as fluorite on the left or biotite on the right. There's many more rocks. It can also become present through industrial effluents. So since fluoride has multiple avenues of introduction into water sources, drinking water needs to constantly be monitored. There are two major commercially available methods for detecting fluoride in water, and these are the ion selective electrode method and nuclear magnetic resonance spectroscopic analysis, or NMR. So the ion selective electrode method measures the activity of ions based on a sample's electrode potential. So if you look at the diagram, you can see that there's a reference electrode present, which will detect electrode potential. And then there's a sensing electrode. So in this case, a fluoride selective electrode would be the sensing electrode. The procedures of the experiment would be fluoride would be dissolved into a buffer solution that has a low concentration of ions, and the electrodes will be submerged into the solution, and the ion concentration of the solution will be recorded by the voltmeter, which you can also see. The nuclear magnetic resonance. So this uses magnetic properties to determine the amount of fluoride in water. So there's an external magnet introduced to a sample, which you can see in the diagram, and it's going to reflect the resonance of a sample. I'm not going to go too in depth about this one because it's pretty complicated. So there's some downsides to these commercially available methods. So they need well-equipped laboratories and trained workers. This means that they cannot be used in minimally resourced communities. And they also have low specificity. So this article sought out to help address some of these problems. So the experiment wanted to find a simpler, cheaper, and more sensitive method for detecting fluorescence. So I'm going to give you basically an overview of what they did. They synthesized a compound called 7-O-tert butyldiphenosyl 4-methylcoumarin, and this compound emits blue fluorescence when it interacts with fluoride. So in the experiment, a series of test samples with varying concentrations of fluoride were prepared, and the synthesized compound was added to each. Test samples with different anions were also prepared to see if this method had high selectivity for just fluoride, and then the emissions were recorded by the spectrofluorometer. And the spectrofluorometer was determined to be simpler to use, more sensitive, cheaper, and have lower limits of detection. So Lauren and Joseph are going to go more into detail about the specific instrument used in the article and the results from the experiment.
All right, my name is Joseph Stark, and I'll be addressing the experimental portion of this journal article. So first and foremost, going over the objectives. Really, the main goal of this article was to devise a method to monitor fluoride levels in prospective drinking water. The main reason for having this goal is because high fluoride concentration has in the past been linked to ADHD and increased rates of type 2 diabetes. In addition, fluoride just generally isn't that great in high consumption. It's okay in moderation, even beneficial, but whenever the levels get too high, it gets dangerous. Now, of course, other methods do currently exist for finding fluoride concentration, but that really isn't accessible to impoverished regions of the globe. It's either too expensive or requires too much infrastructure. A great example of current methods failing can be the Haitian crisis a few years back, where natural disaster really struck an already impoverished region, where after the natural disaster, they didn't have the labs necessary to test their water, they didn't even necessarily have the power needed to run the equipment. Beyond that, current testing at the time was too expensive for them to obtain in bulk, and they relied on donations that really just wasn't enough. So with that, this paper tried to develop a compound that could effectively have a low-cost, low-infrastructure method to determine fluoride levels in water. Now going into that method, the paper identified a novel 7,0-terpbutyl diphenylsilofluoromethylchloramine compound that I will not pronounce again, and selected it as a producible compound that should bond in such a way that a water sample with fluoride in it would fluoresce under a simple black light. You can see that compound taking effect in the bottom, where at the right you have the full compound, then fluoride bonds with it, creates a break where one portion will fluoresce and the other portion will just be background in the water. Now, following this, there was a synthesis of the compound, but as that's mainly organic chemistry focused and we're looking at the analytical aspects, we'll move on to the testing of it. For the testing of purity, NMR was used as is common in most organic chemistry practices, and then after confirming that the target compound had been produced, it was tested for effectiveness with fluorescent spectra. Looking to the NMR, as I mentioned earlier, it was produced through organic chemistry means. And as any of us who have taken organic chemistry know, or any of us who have studied organic chemistry know, after you create a compound, you always test it with NMR to confirm that you created what you thought you would, and that's not just riddled with a bunch of background noise. The machine was set up to run at 400 megahertz, and it did confirm the creation and the purity of the compound that I will not try to pronounce. Moving on to the fluorescent spectra of it, stock solutions were created much the same way that we do in lab. For this specific example, they dissolved sodium fluoride into deionized water. The solutions were then diluted down to various standards, the specifics of which were not mentioned in the paper, but they must have been low, considering that 40 microliters at 4% of the solution that I will not pronounce was prepared when THF and added to 1 milliliter of each of the standards. The specifics on the fluorescent spectra were that the excitation wavelengths with 360 nanometers and the emission wavelength with 450. That's about all that they gave for the fluorescent spectra, but it's really just about all that you need to gain an understanding of how the machine was set up. Now, with that, for the results, the experiment was successful in confirming the validity of the compound that I will not pronounce in fluoride detection. Quite simply, fluorescence variation was observable to the naked eye under simple black light dependent on fluoride concentration. Breaking that down, the more fluoride that was in water, the brighter it fluoresced, and you could tell that fluoresced more when more fluoride was in the water. To elaborate on that, you can see in the diagram at the bottom of the page that really only fluoride causes any fluorescence. All of the other compounds that are common background in water or contaminants in water really don't affect it at all. this compound is successful at isolating fluoride and determining if there is an excessive amount in water. However, my partners and I found no evidence of consumer-level production of this compound, so it's unclear if it just isn't economical to produce, or if there was some other method, or if there was some other reasoning as to why it's not in commercial applications. With that, that really ends the experimental portion of this lab, and I'll go ahead and pass it on to my partner.
Hi, my name is Lauren, and I will be going over the specific instrument used in the article that my group chose about testing the amount of fluoride in water using the compound TBDPSC. So the method used for this was fluorescent spectroscopy, and the equipment that they used was a fluorescent spectrophotometer. And in the article, they said the exact name for the instrument they used. It was called a Varian Carey Eclipse Fluorescent Spectrophotometer. And Varian, that is just the name of the company that makes those machines, and then the rest of the name is the actual name of the instrument they used. So first I will begin with the major components of the instrument. On this slide, I'll start with the green. The energy source for this method was a xenon flash lamp. So they used this, well, first they put the sample in the machine, and the xenon flash lamp sends light through it, and just one flash, which is good, so it doesn't, it just does one flash, it doesn't keep the sample exposed to the light, which is better for it. And then after it goes through the cuvette, it goes through the monochromator, which is just the excitation and emission monochromators, and these basically just filter and sort what wavelengths can pass through the cuvette, and in this case it was set to 360 nanometers to 450. So only wavelengths between that range from the lamp could be passed through the sample to be measured. And it's also important to note that the emission monochromator is set at a 90-degree angle for this, and that is basically in order to minimize the amount of reflected light that goes through the sample. So then the light is passed through the detector, which is shown up with the red arrow. The detector is the photomultiplier tube, which it basically converts the light energy into an electrical signal, and that'll be displayed on a graph at the end, and it plots wavelength against intensity. And then next slide, I have the name up here again. Basically, I'll just be going over the analytical information for this machine. Like I already said, the energy source is the xenon flash lamp, and one benefit to this specific machine, not all machines do it, is that it just does one flash at a time, so it doesn't keep the sample exposed to light, which I guess not all machines do that. And then what we measure from this, what they measured in the article from this was fluoride intensity, and that would be considered the analytical information obtained from the experiment. And then the information sorter is the emission and excitation filters, which, like I also said, just sort what wavelengths can pass through the sample from the lamp. So it only measures between 360 and 450. And then the input transducer is the photomultiplier tube in this case. It typically is. A lot of fluorescent spectrophotometers use a photomultiplier tube as the input transducer. And the definition of transducer, it basically just converts information from one domain to another. So in this case, it's just taking light energy and converting it into digital data to be displayed on the graph. And that brings us to the signal processor, which is the digital data displayed on the graph that just shows the amount of fluoride that was in the sample. And for this experiment, they did multiple samples. They didn't just have one sample that had one amount of fluoride in it. They did many that had different amounts of fluoride, so it covered a lot of ground. Anyways, my last slide is over the advantages and disadvantages of this machine. Some advantages are that it's less complex
than some other methods. Even an untrained user could conduct the test, which is nice. You don't have to have a lot of highly trained personnel to be able to use it. Really, you just, set it up, put the sample in, and then you are given the results in the form of the graph. And it is also pretty small. It's compact. The website said it was only 24 inches length and width, so it could easily fit on a table in a lab. And then some disadvantages, though, are that it is not quite as easily accessible or cheap for some lower income areas. So I think if there were areas that might have had too much fluoride in their water, it still wouldn't be as easily to get a hold of this machine if they needed it, just because it's not quite as simple as just buying it online. I think you have to be verified or show that you own a lab or work in a lab to be able to purchase it. And even though it might be cheaper than some other instruments, it still is expensive for some lower income areas. And I believe that's it. I just have my reference on this slide, and that is all I have.